Hi, in this lecture video, I'll be discussing the temperature scales and how to convert the temperature from one temperature scale into another temperature scale. So currently, there are three temperature scales out there that are being used in science and in our daily lives. And those three temperature scales are as follows. The Fahrenheit scale, which is being used in the US. The Celsius scale, which is used by the rest of the world. And then the Kelvin scale that's been used in science. So please note that recall that when it comes down to the temperature, the SI unit of temperature is actually the Kelvin scale. And we'll discuss why that is the case in a little bit. So now let's go over how these three temperature scales right here were established. They were all established based on the freezing point and the boiling point of water. So basically using water as a standard and then setting the temperature based on the freezing and the boiling point of water. So let's first discuss the Fahrenheit scale. In the Fahrenheit scale, the freezing point of water is then set equal to 32 degrees Fahrenheit. And the boiling point of water is then set to 212 degrees Fahrenheit. So whenever water begins to boil in a Fahrenheit scale, that would set equal to 212 degrees Fahrenheit. As you can see, this value right here, 32 and 212, these are not easy value to remember, right? And now let's move on into the Celsius scale. In the Celsius scale, the freezing point of water, so whenever water begins to freeze, that temperature right there is then set equal to 0 degrees Celsius. And the boiling point of water is then set equal to 100 degrees Celsius. So the range from freezing to boiling point of water is then 100 increment or 100 degree. Each of this increment right here is called a degree. So 100 degree increment between the freezing to the boiling point of water versus 100 degree Fahrenheit increment from the freezing to the boiling point Fahrenheit. So the Celsius scale has values that were very nicely defined or established. It's quite easy to remember 0 and 100 versus 32 and 212, right? So this is the reason why that the Celsius scale is being used by the rest of the world. And in fact, in science, we do use the Celsius scale quite often. But the only reason why this is not the SI, not the standard unit of temperature, is because of the negative value. In the Fahrenheit scale, and both in the Celsius scale and the Fahrenheit scale, we will be running into negative temperature. So although the Celsius scale is very, very popular and commonly used, we run into negative temperature. And this negative value right here actually are not convenient in mathematical equation, because this negative value here changes the sign in mathematical equation, and thus not convenient. And sometimes they can actually ruin the equation. But the scaling in the Celsius scale is actually pretty good, and we like that. However, we don't like the negative temperature in the Celsius scale. So that is the reason why that the Kelvin scale was established, to basically get rid of the negative temperature, to avoid the problem in mathematical equation. So how the Kelvin scale was established is based on the following. We take the lowest temperature that we have ever been able to measure in the Celsius scale, which is negative 273.15, and we call this the absolute zero, because there's no other temperature that will be colder on this that we have ever been able to measure. So this is the coldest temperature ever reported or recorded. And in this case right here, we will then set that equal to 0 Kelvin. So the coldest temperature in Celsius is now equal to 0 Kelvin. And because the increment in the Celsius scale is really good, and therefore we want to also adopt that same scaling into the Kelvin scale as well. So the range in the Kelvin scale and the Celsius scale are the same thing. 1 degree increment in the Celsius scale equal to 1 degree increment in the Kelvin scale. And now, because the negative 273.15 equal to 0, and they both increase on the same range. So therefore 0 degree Celsius will then equal to 273.15 Kelvin, and that would then be the freezing point of water. And to the boiling point of water, so the increment would be the same thing. So basically 373.15 would then be the boiling point of water in the Kelvin scale. So that's the relationship between these three scales and how they were established. Now, we need to be able to convert among these three temperature scales right here. So let's go over some of the mathematical equations, how to do this. How to convert between the Kelvin and the Celsius scale. So the equation is as follows. Kelvin, the temperature in Kelvin, equal to the temperature in Celsius plus 273.15. And the reason why, because 0 Celsius equal to 273.15 Kelvin, and they have the same range. So we simply take the temperature in Celsius and plus on add 273.15 to it. And that would then give us the temperature in the Kelvin scale. And now, in this case, this equation is now solved for Kelvin. We need to also be able to solve for Celsius as well. So solving for Celsius, we have to subtract 273.15 to the other side. So therefore, the degree Celsius would then equal to degree Kelvin minus 273.15. So there you go. That's the equation, how to go back and forth between these two equations. On your exam, you'll be given one of these equations, and you have to be able to solve for the other equation. And here are the equations to convert between Celsius and Fahrenheit. Celsius and Fahrenheit are related by this equation right here. So the temperature in Fahrenheit equal to 32 plus 9/5 times the degree in Celsius. So where did this 9/5 come from? This 9/5 right here is due to the fact that 1 degree increment in Celsius is then equal to 9/5 the increment in Fahrenheit. And the reason why as follows: 180 here and 100 over here. So we can reduce this to 9/5. So that's where that 9/5 come from. And this is an exact value. And 32 is also an exact value as well. So that's how we would convert between the Fahrenheit scale to the Celsius scale. And again, make sure you know how to solve for Celsius from this given equation. So in this case right here, to solve for it, to solve for Celsius, we have to first subtract 32 to bring it to the other side, and then divide both sides by 9/5. So therefore, the temperature in Celsius will then equal to the temperature in Fahrenheit minus 32 over 9/5 on the denominator. So that will be some of the equation right here that make sure you are familiar with. Now notice the following. There's no direct equation to convert between the Fahrenheit scale and the Kelvin scale, but they all go through the Celsius scale first. So if we need to convert between Fahrenheit to Celsius, we have to convert Fahrenheit into if we need to convert between Fahrenheit to Kelvin, we have to convert that to Celsius first. So first convert Fahrenheit into Celsius using the equation from above, and then use the other equation to get from Celsius into Kelvin. And lastly, let's now discuss the rounding rules in temperature. So the rounding rule in temperature conversion is as follows. Round the final temperature to the same number of decimal places or place as the starting temperature. So if we start in the temperature with the 1 decimal place, measured to 1 decimal place, then on the final answer, we'll be reporting our answer to 1 decimal place as well. Versus if we were to start from the 1 place on the temperature, then the final temperature will be rounded to the 1 place as well. For an example, let's say convert negative 25 degrees Celsius to Kelvin. So in this case right here, we have to convert Celsius to Kelvin. And the equation is as follows. Kelvin is then equal to degree in Celsius, which in this case right here, negative 25 plus 273.15. And solving for this equal to 248.15. And now we have to round this to the 1 because we started with the temperature in Celsius to the 1 place. So we have to round this to the 1, and that equal to 248. Okay. And the reason why that we have this rounding rule right here is simply to make it easy, but it does indeed follow the rule of addition as well. And the reason why is when we add these two temperatures together, this is a less precise value, and we have yet uncertainty exists on the 1. So we're supposed to round our answer to the 1 as well. And there you go. And now let's try another example. Convert between Fahrenheit from Fahrenheit to Celsius. So in this case right here, the equation to do this as follows. Degree Celsius equal to degree Fahrenheit, which is 55 minus 32 over 9/5. And make sure we put a parenthesis around the 9/5, so the calculator will accept this value correctly the way it is intended. And this will then equal to 13 degrees Celsius. And we also need to round this to the 1 place as well, because we started with the temperature existing on the 1 place. Now please note that this 32 right here is exact, and this 95 over here is also exact as well, because this value came or were derived from definition, so therefore they exact. But the simplest way to round this is to again go back to our rounding rule. We started with the temperature on the 1 place, so therefore we'll be rounding the final answer to the 1 place as well. So please try this following example to make sure you know how to convert the temperature in these 3 different scales.